Hello again. Welcome to the stream. If you're new here, I'm Jared, a Rubyist. I've forgotten to turn my stream lighting on. So let's do that. Today we're working on Advent of Code. Previously, I got stuck on day 22 trying to come up with a solution that was adequately performant. That looks better. I think I was really just missing a couple things about how we could detect overlaps and stuff. Been having some trouble wrapping my head around the 3D ones this go around. But I have a pretty good idea how we want to do this. Talk to some people who obviously get these 3D ones a little better than I do. And I think we're in a good position to try and knock this one out here. So we're coming back. Whatever I had previously was not working at all. I've got a simple day one spec here that sorry. Let's take you back to the code. I've got a simple day one spec here that I think should work for our purposes here in terms of demonstrating this thing. This whole approach though. Nope. So this is our part one that we're working on here. Part two only changes in that we don't constrain range. So, I mean, we've got. So first of all, I mean, what did I call this? There it is. It's volume, right? We're not going to do all this subdivision stuff. That was not a successful approach. This should be called volume. Sorry. Okay. I have to be right back. I just have to go make a phone call. All right, we're back. Sorry. Just called about an appointment later that needed to be rescheduled. Means I got more time to do Advent of Code. All right, so we've got our cuboids, we've got our instructions. I don't really like how I did this. I feel like an instruction should just be a thing we do in a cuboid. Right? We don't. And so got this thing, but now what we want to do is just generate a cuboid. Rather than doing all this work, this can fall under actual just create a cuboid. Why don't I have? Sorry, just wanted my stream stats up. Excuse me. These are like ranges. And so I think we need to conditionally. Ooh. One more. There we go. The cuboids are just going to have the start and ends. They're not going to. We don't want to be working with ranges. That's just a product of the fact that this is valid. These second parts of these is valid Ruby, so I just eval it. I'm sure if you're offended by, that's fair. So that can. We don't need 2 cuboid anymore. So actually, that's basically just the code we need to construct the cuboid. So let's just use that. And then this is XR. Just put a bunch of R's in here. And then I think finally using X start and X end was just a lot of typing. We can just use X. Now that some of my friends who did this just use X1, X2, and that seems easier to think about. It's just a lot of math we're gonna have to do, and once we get into mathy stuff, I feel like it's chill to just use a bunch of numbers, you know? Okay, so where are we at? We also gotta update these. So end, start, end, start, end. Cool, and now it looks nice on my line. Look at that. Isn't that nicer? So we have a stepped up cars. Step has a cuboid now, and on, and now we should be able to like iterate over the steps, do something with each of them, come out the other side. See how that works. Cool. I mean, we can put a bind out fine there. See if our steps look the way we want. On, true, cuboid. I'm sure that's right. We didn't really change it into parsing logic, so I wouldn't expect to have broken that. Cool. What did I run there? Steps. Okay, so yeah. So now the approach that I've talked to a few people. I was very stuck on this one. The approach I like is that we can, now that we were already constraining our inputs. So we can actually even reject the ones that, oh, one nice thing we can do is we can reject steps here. So here, I like following convention, the semantic block convention, or whatever. So step dot cuboid volume 0. We can just not do the steps, because that that's only gonna affect part 1 where our input's constrained. That means that if they're entirely outside the range of the like -50 to 50 range, then we won't do anything with them. So then I think the approach I want to take is we want to go through, and for each step, I guess this doesn't matter whether it's a set or an array anymore. And we're going to flat map each view. So we were kind of getting close to this solution last time, but we didn't quite get there. So cuboids, flat map cuboid. Then we're going to have a what we're going to do is we are going to subtract step from step.cuboid cuboid. And we're going to implement that so that that'll return, like, whereas last time we were trying to like optimistically subdivide all of the cuboids and then sort of use set operations and Ruby equality to come out the other side of the correct set. That was, I think it was probably working, but it was far too slow. It divided the space up way too much. We still ended up with like a impractical millions of operations that we needed to do. It would have probably finished if we let it, but I don't like solutions like that. So cuboid is going to equal cuboids a flat map, and then if step dot on. So if we've so now we've cleared the space for this cuboid that is the step. If it's off, then that's all that we needed to do. We've removed the chunk of space that cuboid takes up, and we're good, and we can move on. If we are supposed to be turning those on, though, it means what we've done is we've removed all of them so that we don't have duplication. We actually want to add this steps cuboid to our list of cuboids. I think that's as simple as we can do here. It certainly seems reasonable. We can okay, so then all we need to do is implement intersection, or this sort of intersection removal operation. I think we do that. So I think we can just this. We have a base case. Oh, we're gonna have to like figure out how to make work, but we can say like return self unless intersecting other, right? If they're not touching each other, then there's nothing no problem here. So one of the things I was having a little trouble with Um, let me just actually bring up the thing that I was shown that helped me. Go. Oh, someone showed me this, which is this nice like for like understanding how intersection works. So this can be this sort of shows you that in 2 dimensions, in order for something to intersect, all of these conditions need to be true. So the first x value, x1 here, needs to be larger than the other one. Sorry. This value, a's x1, needs to be less than b's x2, and a's x2 needs to be more than b's x1. And similarly, the same sort of pattern applies for the y-axis. And as soon as any one of those isn't true, then we know we don't have an intersection anymore. This works for containing as well. So we can do this intersecting other. I guess this is technically private method. And so here we do x1 is less than the other's x2, and x2 is greater than the other's x1, and it's actually greater than or equal to, isn't it? Shouldn't that be how it works in this kind of space? So yeah, once they're actually touching. Anyway, hopefully. I think in our space that's how that would work, but I'm not sure that it actually matters. So one other 2 greater than other 1, and we actually need to, you can just do these y's for z's here. I think that should be a valid intersection test. So that's where things get hairy. This is now that we know they're intersecting, there's like 6 possible slices we need to pull off here. And this is where this is one of the things I was trying to avoid having to do last time. So let's see. No, we're gonna have to like uwood.new and so like it's just get our y1 y2 z1 z2. All right. And I know there's 6 of them because there's 6 sides on this thing. So there's different ways you can do this. So if you think about the maximally sliced up cube we could have would be if we have our cube our other cuboid here fully inside of it. In which case, we could pick a few different ways to do it, but we'd want to take the front half to the edge of the cube we're removing, and then and slice off the whole front of the cube, and then do the whole back of the cube, and then we can do a slice off the top, slice off the bottom, because it's kind of hard to visualize. So I just don't remember the name of the draw online tool, like Sketchpad. So it's just to visualize that, make sure we're doing the same thing. If we've got one cube, and then we've got, how do I change the color here? Another cube inside it. Then we can sort of slice it along here and here, here, pull off this cube, and then we can do the same thing on the other side. And so now we've got sort of this slice here, think of it, left, with our inner cube inside of it. So we've just got this middle slice. And then when it's just up to us, like we can slice it there. And then we're left with tall pieces, and one piece here, one piece here. So that'd be 1, 2, 3, 4, 5, 6. And it doesn't really matter, I don't think, which way we do that slicing. We just have to wrap our brains around exactly how it works. I don't know if this is actually helping me. Who knows? So let's think through this. So I feel like this slice is the easiest one to think about right now. So if we treat it's x1, x2, I'm just going to draw everything on here. This is y1. Doesn't really matter which way we pick for y, x, y, z here. That one, and then, oh, what have I done? That's the same axis. What am I, this is, I just labeled my Command Z. There we go. This was a very confusing way to draw this. One, two. I'm really confusing myself by this drawing. This is not how I think about it. I've labeled the axes not the way I want to label them. So I just want X, Y, Z. Okay. That means this one is the full length on the X and Y axis, but only up to the other one Z if the other one Z is existing. So call this bottom slice. And all of these are good, except for the Z2 value. I don't know what to call this. ZZ. Well, I'm gonna need two of these values. It's the like. I'm gonna call it OZ1 for like other Z1. That's for terrible naming, but it's what we're going with now. So OZ1 is so it's the bottom, it's the lower, it's the other, so we're doing something with the other Z1. So it's the maximum value, right? The maximum value of the other Z1 and our Z1. So it's either if the cube is missing it or coming up from below, we just want to slice at the bottom level of ours. Otherwise, if it's intersecting, like in this case, we want to slice along this plane here. But we also want the minimum value of the top of our Z2. Well, I'm gonna have to do this for all of these. Okay, I think that gets us our bottom slice. So let's do the top slice now. This one again, our X1, X2, Y1, Y2 are all the same. But we're going from, and I think our Z2 is even the same. We're just going to change Z1 because we only want to slice from here to the end instead of from here to there. And so this will be our Z2. So it's the other Z2. But it's it has to be at least the bottom of this, right? For us to slice up. So we'll use our Z2 here. And then I think we're still maxing on Z2. Does that make sense? Something feels weird to me about that. Why would we be taking the max and the min? What is this case covering? So Z2 is, the other Z2 is less than Z2, so that's this one. So it's below this. No. That's, oh, I'll be right back. Sorry, I am back. I see my boss. Oh, still got one viewer. Hello. All right, so we were stumbling our way through this. Right. So I decided we were talking about Z2 on the other. So the top edge of the other needs to be less than our Z2. Or sorry, it needs to be the max. Or is that supposed to be min? What am I missing? Or is this... Or are we just constraining it within here? So it needs to be at least the bottom. And most of the top. Okay, there we go. And now it makes sense. I knew I was missing something here. Okay. That looks like a reasonable bottom slice. So now we need another slice. What do we do? We can take these thin slices. And then we can do the little end cubes, maybe. We might as well move from least constrained to most constrained, so that I understand the problem better as we move through it. So I don't know if any of my very few viewers have noticed, but there's always lyrics from some of my favorite music in the corner here. My status changes every hour, and it's a random selection of them each day. That's the Protomin. Mac 2. So this one is going to, so these two, so we can call this left slice and right slice. I'm sure everyone picked totally different namings for these, but we know we need to go from, this is our OZ1 to OZ2. So we know that's going to be the same for both of these. However, one of them is going to go from OX1, I don't even know what I'm trying to OX2. And the other one is going to go from OX2 to the end. So we do that. Left slice is going to go to OX1. Right slice is going to go from OX2 to X2. And so now we just have to figure out what these are. But I think they're just going to follow the same pattern here. I think I can just replace all these Z's with X's. No, I can't, because because there are X's that aren't in, that are in the word max. Had nothing but a glass of eggnog today, so after I finish this, I'm definitely gonna go find some food and then come back. So I guess we can just fill these out with the remaining so now we got X, Y, Z. I think those are all just, I don't need to think anymore about that. So now we have our end slices. So these ones, so our first one is going to go from Y0 to, so let's talk about the constraints that are the same. They're already sliced up, so they should be inside of OX2 and then also Z1, OZ2. Then we're gonna do the same thing. So this is gonna go to, one's gonna go to OY1, and then one of them is gonna go from OY1 to OY2, or from that's wrong. So this is the front slice, and this is the back slice. Calling this face here the front. Cool. That looks vaguely like it, right? Would be right. And I know that we are going to need to project any of these where the cuboid's volume is 0. I don't know, this kind of looks like it might work. What have we done wrong? Now we spelled volume wrong. Good start. Now we just got a hugely, hugely wrong result. Well, that's cool. What? Where do we start debugging this? I mean, it's a very wrong result. I guess we can try and step through it, but it's really tough. So steps on, step has a cuboid. Goes from step through that step. And so we should have a single cuboid. In here. Let's see, do these ones intersect? They start on the same x value, they end at a different. What do we get here? We get 3 cuboids. So apparently they've intersected. I think these ones intersect though. Why can't it? It's a private method. Sneak around that fact. Not intersecting. So x1 is less than x2. x1 less than x2. x2 is greater than 1. z1 is less than z2. 2 is greater than z1. And that looks like so I've seen one of my friend's solutions and it doesn't have equals here, but I feel like there should be. Not too bad there. We're getting such hugely wrong results that it's very difficult to debug. I assume it's producing wrong results for everything. How am I getting such a large negative number? Am I like constrain range not working? Yeah. And this all looks right. How am I getting such hilariously wrong answers? I don't want to write tests for all of this. I don't know how to debug this. It's really hard to think through, like just going through this logic is a pain in the butt. I don't really want to have to do it all. Thinking it through enough to like write tests for it too. Thought we talked through it pretty good and it was right. What could we be doing wrong? Getting volume correctly? That's 2 minus x1. So 2 minus, yeah, that's how you compute volume of a cube or of a cuboid. Take a look. Well, that's not constrained. There's that. So constraint range is true. Passing constraint range in here. Constraining the ranges of these all. So constrain range is true, yeah. change. No change is expected. Just looking for a oops, okay. So this is not working. And that's a start. That's funny. So my constrain method, missing that. I think. Doesn't really matter which order you do it in. All right. Put our pry back in here. Make sure we're constraining the area correctly. Examine our steps. Am I getting half? That's not half, no. It's almost half though. But I saw the 28 and the 59. I was like, wait a second. But no, not quite half. Or a little more than half. Or a little more than double, whatever. A little less than half. Suspect. Same number. Doesn't appear to impact anything with our input. There's still 22 inputs, which is weird because this one spans across a value of the X range that's completely outside. So that would suggest to me something's not working here. Well, I need to add my bind.pry back in. Look at our inputs here. So x20, x26, minus 36, 17. So those are good. Those are good. And Oh no, we're filtering them out correctly now. Okay, never mind. Not that. Not. Oh, it was just some kind of parsing error. This all looks right. This one. Clamps look right. Don't see it. Oh, maybe? Maybe the issue is that there is something to do with the greater than or equal to that I was missing. That doesn't help me. It's going to be the wrong value. How do we do about this? Okay, well, no inputs appear to be getting parsed correctly. They all looked good. That couldn't be it. Constraint range is now working correctly. I guess I can run against the other one to make sure I'm getting similarly erroneous results. At least I can. It's getting like, this isn't half though. This is like less than a third now. Yeah, so we got about a third and about a half. The right results is upsetting, to say the least. I think our intersecting is right. Maybe there's something there. No, I mean, those look all right. What the heck am I missing? Minus top, and we're doing the right. We're treating the minus as other. Not mixing up any of our coordinates in here. Those are x's, y's, z's. Oh. I don't think this has anything to do with anything. I don't think I even technically need that. Yeah. Puzzle maybe? I don't know. And I think these should be. I mean, it's hard to draw it out. I mean, let's maybe draw it out in 2 dimensions just to make sure I'm not losing. So, if you can, God, can I zoom? Zoom. 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay. We have this. I'll just do it in 2 dimensions because this one would be. This is 0, so this would be 1. So its x would be 1, 2, 3, and so does y. And that matches up. So they're telling us 10, 11, 12. Yeah. Inclusive. We had another one. Here. You would also have 1, 3 here. I'm not worried about. But it would have 0, 2, 3, 4, 5. Yeah, it's greater than or equal to. We could even position it here to really drive that home. So that's 3, 5, 3, 5. I guess that these are supposed to be equal signs. Fresh, exciting, incorrect result. Now we're slightly less than half. Okay. Does that mean I should be factoring in this somewhere in here? I feel like maybe it does. Two dimensions, so then we're doing our splitting. We have this, we have this. How's this gonna work? So let's say, let's orient this one at 0. So this is 0, 2, 0, 2. Its friend here is 2, 5, and 1, 0, Yeah. So we want to end up slicing off. I feel like I need +1s or -1s or something somewhere. But it still feels weird that we're so far off. But maybe it's compounding somehow. Maybe I'm like undercounting consistently at different steps or in how I'm splitting. Oh, for sure I am. I feel like I'm overcomplicating, but there's a simpler way to handle this. I didn't see this complexity in my friend's solutions. We want, in this case, we want to end up with one that is 0, 0, so 1 wide, and 0, 2. And then we want to end up with one that is 1, 2 tall and 0, 1 wide. So in this case, our OX value is 2. I should have to Y. 1. No, that's OX. And our Y value is 1. So if I slice from zero to, oh man, what am I missing here? I feel like take those out and I just need to add like oh, wait a second. I should be able to just add on to the ends and I think everything will work. I need them to still be constrained. Okay, I can put +1s in there. I think that's not gonna work for, no. I mean, that looks like even closer to 0.5. Well, homing on a result that's exactly 50% what it's supposed to be. That doesn't explain, but I have no idea why that's happening. All right. I am in need of food, so I'm gonna take a break again. I might play around this a little bit, but I will come back and stream stuff, debugging, figuring out what the solution was and getting this working. So thanks everyone for coming out. I will See you later.